My name is Yongtian Zhang. I'm a senior security consultant in Kaiser Permanente. So I work in Kaiser for cybersecurity. Most of the time is penetration testing and security assessment. So basically, we try to find the problems inside the system or application. And I think I'm swapping with another presentation for OWASP 10. So we are actually the two topics are really very closely related. So we are both on security side. So the topic I want to talk about is the called zero trust with user, because I know this conference more like a software quality. So security is a very major part of the software quality today, especially nowadays. Most of applications they are online, right? A web application or mobile applications. So I will kind of talk some my observations during my tenure in Kaiser, with my testing experience with all kinds of different applications. Uh, so I know from a software perspective, so and most of the developers, uh, when we develop application, right, we follow a happy path. I think most of the time we call happy path. So basically, that's the functions need to provide the user. So we break that workflow into multiple modules, and this is very high level, very simplified workflow, right? User trying to interact with the application, and if right now most of time application will validate that user, so go through a third party or internal authentication process, right? Most of the time it's a Active Directory Windows authentication. Once the user authenticate, then application will kind of bridge user to backend data to receive request and send back response to users. Most of the time, it's a web application or mobile application. So this is a happy path. I think we see developers or QA people, they normally test user functions, right? Functionalities. Of course, security is also part of the functions. Every time when we do the testing, the pen test or security assessment, the normal security functionality has already been tested by QA group. So they've already passed the most all uh, functions like authentication, authorization, everything is fine. So they come to us, say, "Oh, can you find some problem maybe?" So we try to follow the unhappy path actually, because happy path already been tested. So uh, the problem nowadays a lot of time is user is authenticated, but from developer perspective, I see a lot of developers they say, "Oh, if we find some problem inside the application after authentication, they will say, why this is a problem? Because user already been authenticated. They are already authorized to do this stuff, right? If there's a problem, the user, we trust our users. So the point I want to make is, no, we really don't trust our users because user has been authenticated, but that user could be malicious users, right? There may be someone inside your network, they have access, but they have malicious intentions. They want to sabotage, they want to revenge, or they want to steal your secrets. Or it may be a attacker. They somehow get hold of user accounts. They somehow compromise user computer. They can come in through a valid session, right? So we don't. So from attacker perspective, we try to follow the unhappy path. So here, so I want to say when we develop applications, we want to have zero trust with users. Even user has been authenticated, we still don't want to say, oh, because user has been authenticated, so yeah, we trust that user. No, that shouldn't be the case. Um, some simple examples like we know there's a if we check the OWASP top 10, they have a cross-site scripting. Right. So I assume everyone here, if you are a developer, you know the problem that actually happens when users send some unexpected or malicious code through web request, and on the server side, server doesn't filter out that malicious code, right? So we cannot trust the user input. That's user input part. So yeah, you expect letters, characters, numbers, but they send you some special characters that mean different things on operating system level or application level. So and another one is maybe the session user login, but he's not aware the session has been hijacked by a malicious user, attacker. So attacker actually kind of write the session, but trying to do something unexpected. And another example is injections. So this can be like a command injection or SQL injection. Uh, it's related to cross-site scripting, but it's a different. It's more like a attacker trying to. Its attacker already gained access to the session and trying to inject some malicious code into the application. So this is kind of the one side of the zero trust because we cannot trust the data from user because data format may be different, may be malicious. They may send you some unexpected characters or commands. So we need to filter out all those unexpected characters and commands. We cannot trust the input from users. So that's the input part, maybe the syntax, maybe the character set. Yeah. So that's the input part from users. So we want to filter out the input. We have seen all these examples in the real applications. So this part of, I would say, part of the zero trust, why we cannot trust users. And another part is even a user, we already authenticated with the user, right? And user, we in web applications, we normally, after user has been authenticated, there's some like session tokens, like a HTTP header, right? To say, okay, I assign you a token, and we know every time you come to me, send me a request, I will validate the token, and I know it's you. So once I know you have a valid token, I will trust your request. I will process your request. So this kind of more a little bit further than the first one because at this step, you probably had already figured out like a cross-site scripting. So, oh, there's no special character in this command. Okay, in this request. So the data set, the character set, they are all legitimate. But what happens is even user coming through a valid session, a malicious user may try to exceed the permissions or authorizations, trying to do something else. There's a notorious example. It's called HRR, the healthcare AP, basically a healthcare API attack like 2 years ago. So there's a third party clearhouse to receive users' requests, and the clearhouse will connect to backend healthcare provider, not Kaiser, so other organizations, and will send back users with their request for their like a medical record or something else. But the problem is that because it's an API call, right? The API call user has been authenticated. There's an API request, but the problem is the user request, their request number or the user, the ID number is sequential. So the user, if the bad guy actually saying, okay, I can register a valid user, right? And ideally, you should only see your data. You should not be able to see other people's data. But the attacker actually uh, just try to increase the request number, and actually he was able to obtain other users' healthcare records. So the session is valid, user is valid, but the application side failed to kind of valid users' request, every request for the roles or permissions that user can have. So that's basically, so we cannot really trust users about their permissions and roles. Every time when we receive user request, we need to validate the roles and permissions associated with the request. We cannot just blindly trust, oh, that's a valid user, the valid data set, valid request. But does that request have like a abnormal or unauthorized access? Right. Another
Hey,
one
Young,
is yes.
I'm gonna interrupt you because we are running a little bit
Oh,
over time.
oh, sorry.
So if
1 minute
you want to
maybe?
wrap it up,
Okay,
I
one
can
minute.
give you. I'll give you a minute. Yeah, if you
Okay,
want to wrap
sorry,
it up.
I didn't I didn't watch the clock. Yeah, so another one. Okay, here's a quick example. So sometimes the web application will use the web token, GWT token, as authorization token, but this token is signed, supposed to be very secure. And you can see the role is defined inside the payload. But the problem is a lot of applications, a lot of applications, they really don't validate the signature of the token. So the bad guy could modify the role and escalate their roles. So this, and another one is the logic holes. So we see a lot of applications, they have small problems there. They have some very small problems and they think, oh, that's fine because a small one and it's not a big deal. But from attacker perspective, they can link the small problems and put them together and do really big damage. One good example is user password reset. I see in the real vendor application, you can reset a password, but when user submit a request, the application failed to check that user actually trying to reset his own password. So he actually user can, well, of course, the data user the attacker has to modify data, but yeah, that's something you can do. All right, okay, I think time's up, and I think that's three perspective that why we cannot have any trust with users and when we develop applications. All right.
It's
All right.